Hi there, so today's lesson we're going to be looking at 7.3 angles in parallel lines. Our objective for today then to identify corresponding and co-interior angles and to be able to solve problems using properties of angles in parallel and intersecting lines. Before we start, let's just check our prior knowledge. So this is what you should know already from previous lessons before you start today's lesson. You should know that angles on a straight line add up to 180 degrees because there are 180 degrees in half a turn. You should also know that angles around a point add up to 360 degrees because there are 360 degrees in a full turn. We should know that when we have two straight lines that intersect, they form two pairs of vertically opposite angles. So A equals C and D equals B, and we use the reason vertically opposite angles equal to describe those. You should also know that angles in a triangle add up to 180 degrees, so that's any type of triangle will always add up to 180 degrees. And you should also know from last lesson that if we have a pair of parallel lines with a single traversal line, so a diagonal line going across them, that forms 8 angles, of which there are 4 obtuse angles that are all identical and 4 acute angles that are all identical as well. So our vertically opposite angles are equal, and this vertically opposite pair is the same on both of our crosses. Before you move on, just make sure that you've checked that prior knowledge, you're happy with that. If you're not, please stop the video and go back and do one of the previous lessons before you move on. Okay, so angles in parallel lines. So last lesson we looked specifically at alternate angles, and if we remember, alternate angles are alternate because they're on alternate sides of our traversal line. So we've got an acute angle, therefore they must be the same size, and they are on alternate sides of that traversal line. So we say alternate angles are equal. Now there are 2 more types that you need to be able to identify that have their own special names. The first of those then is corresponding angles, and corresponding angles are equal. So we've still got our 2 parallel lines and we've got our traversal line going across, but this time we can see we've got an obtuse angle here and an obtuse angle here, and they're both on the same side of that traversal line. So if they're on the same side of the traversal line and they're the same size, they're called corresponding angles. Now to identify those, just like we could look for a Z shape when doing alternate angles, with these we can look for an F shape. So it may be forwards or it may be backwards, but we can use this F shape to help us to identify them. Finally then, the third type that we need to know are co-interior angles. Now co-interior angles are not equal, they add up to 180 degrees. And we can see that here because we've got one obtuse angle and we've got one acute angle. So they definitely can't be the same size, but they will add up to 180 degrees. And the reason that's the case is if I were to take this angle B here, then this angle up here would be its corresponding angle. So an acute angle and another acute angle on the same side of our traversal line would be equal. And if I were to have those 2 angles together, angles on a straight line add to 180 degrees. So therefore these 2 must also add to 180 degrees. Now the way we identify co-interior is that they are on the same side of the traversal line, but they're both inside the parallel lines. And again, if we want to look for a letter, we look for this letter C. So this C shape for co-interior helps us to find those, and it's always where one is obtuse and the other is the acute angle. So the 2 together add to 180 degrees. Please pause the video now, make a note of these. It might be worth copying out those diagrams. This is the key part of the lesson. You need to understand those before you move on. Okay, so now that we've got those rules written down, we're going to have a go at using them. So today we're going to use all of the different rules that we've looked at so far. So that's all the ones from prior knowledge and the 3 you've got on the screen at the moment. So in our first example then, we've got our two parallel lines marked with the arrows, our traversal line, and we've been asked to find the angles x, y and z and to give a reason. So remember, the reason is simply the rule we're going to use to work out the size of that angle. So we usually start in alphabetical order, so we'll start with x. So here I can see I've got this sort of backwards C shape. I've got two angles on the same side of my traversal line and they're both inside the parallel line, so I'm going to need to use co-interior angles. We've got an obtuse angle and an acute angle, and they will add to 180 degrees. So 180 minus the 126, 54 degrees, and our reason, co-interior angles add up to 180 degrees. Now we're going to have a look at finding angle y then. So if I start with the 126 degrees here, the y is on the alternate side of my traversal line, and they are both obtuse angles, so they must both be the same size, but they're on alternate sides of the line, so we're going to use the rule alternate angles are equal. And finally for z then. So if we compare it with our 126 here, they're both on the same side of the traversal line and they are both obtuse angles, so must be the same size. So z must also be 126 degrees, and we call those corresponding angles are equal. So corresponding, remember, on the same side, on the corresponding side of the line, if you like. Okay, let's have a look at a second example just to make sure we're happy. So again, we've got our parallel lines. So this time they're facing in a bit of an angle, but these are our two parallel lines. This is our traversal line. So again, let's start with x. So if we compare that to the 119, they're on the same side of the traversal line and they are both obtuse, so they must both be the same side. Remember, if they're on corresponding sides of the line, they're called corresponding angles. So x is 119 degrees, corresponding angles are equal. Then let's have a look at how we can find y. So we now know x is 119, so we can use that to help us to find the angle y. We've got a straight line here. We know that angles on a straight line add to 180 degrees, so 180 minus 119 is 61 degrees. And we've stated our rule, angles on a straight line add up to 180 degrees. Finally then we're left with angle z. Now we have a couple of choices here. I could use angle x, which I know is 119, to find z, or I could use angle y, which is 61 degrees, to find z. If I've used angle x, then z is 119 degrees because vertically opposite angles are equal. If I've used y to find it, then I've got a straight line here. Angles on a straight line add to 180 degrees. So 180 minus 61 would also be 119 degrees. So you've got to choose which one you've spotted. Personally, I used vertically opposite angles equal. That was the first one I saw to use, but you could have a slightly different answer. Pause the video if you need to. Make sure you're happy with all of those angles and the rules that we've used. All right then, so now it's your turn. So for each of the diagrams, you need to find the angles labelled with the letter, and don't forget to give your reason for each answer. Pause the video now and have a go. Okay, so let's start off with question A, finding angle A then. We've got them on the same side of the traversal line, so on the corresponding side of the line, and they are both obtuse angles, so must be the same size. So 115 degrees, corresponding angles are equal. For the next one, for B, again, 95 and B are on that same side of the line, and they are both obtuse angles, so must be the same size. So B, 95 degrees, corresponding angles are equal. And for C then, well, now that we know that B is 95 degrees, we've got a straight line here, so we can use our angles on a straight line rule to find C at 85 degrees. Moving on to question C then, we're asked to find x. So we've got two choices of angles we could use to help us to find x. So again, let's look for the shapes. We've got this F shape here. So two angles on the same side of our traversal line. Both of them are obtuse angles, so must be the same size. So x is 95 degrees. Corresponding angles are equal. Check your answers there. Make sure you're happy before you move on. All right then, so a bit of a challenge for the last thing for today's lesson then. So we've got our two parallel lines and we've got our two traversal lines here, and you're asked to find the angles marked with the letters for each of these. So pause the video, have a go, see how many of those you can find, and don't forget to give reasons with each answer. Okay, let's talk those through then. So again, I'm going to do them in alphabetical order. So starting with W, we've got 42 degrees. Alternate angles are equal, so I've used the 42 here with the W on alternate sides of our traversal line. X then, 42 degrees as well. I've used vertically opposite angles are equal. And then Y, we've got on the same side of our traversal line both acute angles, so 75 degrees, corresponding angles are equal. Looking at our second diagram then, so I'm going to start with A. So we've got a straight line here, so we can use that to help us. So A is 132 degrees, angles on a straight line add up to 180 degrees. Now I'm going to find angle B, so I've got some choices. If I look at B and 48, they're on the same side of my traversal line and they are both acute angles, so they must be the same as their corresponding angles. Or I can see that I've got an A and a B that are both on the same side and both inside the parallel lines. So with one obtuse and one acute, they add to 180 degrees. So I could have used co-interior angles either. So remember, you only have to use one of those two rules. For C then, we've got the 120 degrees here to help us. So C and the 120 on the same side of the traversal line, and they are both obtuse angles, so it must be the same size. So 120 degrees, corresponding angles are equal. And again for D, I've got some choices. I can either use angles on a straight line, so D and 120 together must add up to 180 degrees, or I can use C and D together as co-interior angles, add up to 180 degrees as well. So D is 60 degrees, and again, one of those reasons. Well done if you managed to find all of those. Okay, so thank you for working through today's lesson then. Please click on the link to move on to the next lesson when you're ready.